This diagram shows the action potentials of both ventricular fibers and the sinus nodal fibers. This green line, you can see that this is the action potential of the ventricular muscle fiber, okay? And we have already discussed it in the previous lecture. This is phase 0, okay, followed by phase 1, phase 2, and then phase 3, and this phase 4. So I have already explained all these phases. The details about the ventricular muscle fibers. But this red line, if you follow this is the action potential of the SA nodal fibers, okay? These are the membrane potential changes in the SA nodal fibers. Now if we look at this carefully, closely, you see that if you compare their RMPs, the resting potentials of the ventricular muscle fiber and the sinus nodal fibers, you will see that the RMP here is -90. The RMP in the ventricular muscle fiber is -90, the resting membrane potential. But here the resting membrane potential is -60 or -55. So this is one of the differences, okay? Here the RMP has a very low negativity, okay, as compared to -90. The second difference is that here the RMP is stable, okay? As long as the fiber is not excited, this RMP is stable. It remains at -90. You see this is a stable one. It remains at -90 until the fiber is excited. When the fiber is stimulated, an action potential is then generated. Otherwise the RMP is very stable. But look at here, even without stimulation, even without getting stimulated, this RMP is not stable. And you see it gradually, the negativity inside the nodal fiber gradually decreases from -60 or -55 to -40. So over here it is -55, and gradually this negativity is reduced till it reaches -40. And this RMP, since this is without any stimulation, no stimulus is being given, so this is a resting membrane potential, but this is not stable. This is unstable resting membrane potential, and the unstable resting membrane potential is a characteristic of the SA nodal fiber. We don't see unstable RMP in the ventricular muscle fiber, but unstable RMPs are present in the SA nodal fibers, and we will see what is the mechanism of this unstable resting membrane potential. And this kind of resting membrane potential is also known as pacemaker potential. Such kind of RMPs which are unstable are known as pacemaker potential, okay? So let's see another